Okay, good afternoon. Let me solve some problems related to the last part we talked, and then we switch to this new module, okay? So do you remember we talked about the Riemann sums, and then the limit of the Riemann sums, if the function is integrable, it can be interpreted as an integral. So this will help us to be able to calculate the limits of some sequences using the integral, okay? So and it needs a little bit practice. I told you that the formula that I wrote in the notes is the only one used in the exam problems, okay? So this is why I highlighted that for you as a theorem. But in principle, nothing specific, there is no something specific about that particular Riemann sum. But let me just write that one for you. So we had this limit. So this is the phrase, if f is integrable on 0 and 1, then the limit of 1 over n sigma of f k over n. But you remember there was a typo in my notes. Please fix it. It should go from 1 to n, and n goes to infinity. I had written it was 0 in my notes. But the sum becomes the integral from 0 to 1, f of x dx. Okay, so, and the reason is that this is a particular Riemann sum for the interval 0 to 1, yes? Okay, so let me ask you to calculate this limit. So the limit of sigma n over n squared plus k squared, k goes from 1 to n, and then n goes to infinity. Okay, we want to calculate this limit. Okay, so if you can realize that this can be solved using the idea of a Riemann sum, then it is not that hard to engineer the sum in a way that it looks like this, so that you can guess the function here, because you don't know the function yet, yes? But for example, can you tell me how I can engineer this sum so that this sum looks exactly like this sum? One point that you have to be careful about is this factor of 1 over n, which you don't have it here, it's missing here. So this in its own is an indication to make 1 over n appear here, okay? So then this is probably the first thing that comes to mind if this problem is supposed to be solved using this formula. So then I would write the limit. So I would write 1 over n here, but I cannot just add some factor there unless I do something to compensate for that, yes? So what I do, instead of writing n here, I write n squared, and n squared plus k squared, okay? N goes to infinity. So I hope that you agree, this is exactly the same thing. What motivated me to do that? Because I want to have this 1 over n be seen somewhere before this sigma, yes? Okay, the next thing that we want to do something that this becomes f of k over n for some f that you need to be able to guess that function. So you need to see this combination of k over n in this expression. But there is no k over n involved here unless you do something that you can see k over n appearing there. So can you tell me what to do so that you can see k over n there? What can I do? You want to have the combination of k over n. Any suggestions? Divide by n squared, thank you. So you divide everything by n squared. This becomes 1. This becomes 1. This becomes k squared over n squared. But do you agree that k squared over n squared can be written as k over n totally squared? Yes? Now, I want to give the role, if possible, of course, I want to give the role of f of k over n to this function, to this expression that you see here. Is it possible? Yes. In principle, what you need to guess for the function f of x is what is replacing k over n with x. So this becomes 1 over 1 plus x squared. Okay? This helped me actually to guess my function, but let us double check. Do you agree with me that if this function f of x is defined in this way, then this expression that you see is nothing except f of k over n? Yes? Because I have replaced x with k over n. So everything is now okay. Now, before solving the problem, you have to make sure that this function is integrable on the interval from 0 to 1. Is it integrable or not? Yes. Why? Because it is continuous. Yes, this function is continuous, so then continuity implies integrability, so this means that I am allowed to use this theorem. So then what happens, this, instead of calculating this limit, which is hard, what I do, I would say that this becomes the integral of the function that I guessed, but from where to where? From 0 to 1. So instead of calculating the limit, I calculate this integral. But that's the famous integral. So this is, what is a primitive function for that combination is famous. It's arctangent of x, and it goes from 0 to 1. Then it becomes arctangent of 1 minus arctangent of 0. But what is arctangent of 1? It is pi over 4. And what is arctangent of 0 is 0. So the answer to this limit is pi over 4. Yes? Okay, let me give you another example. So calculate this limit. The limit of 1 over n, 1 plus the square root of e plus, the nth root of e, the nth root of e squared, that is the famous Euler number, and then plus up to the nth root of e to power n minus 1. N goes to infinity. We want to calculate this limit. Okay, so in this example, I intentionally want to solve this example because that's not exactly this theorem. So it is a little bit different, okay? So first of all, I think that it would be better if you write this in the sigma form. Yeah, so what I do for answering this question, I would write it as 1 over n, and I would write sigma. What can I write that in principle? I can write the nth root of e to power k, yes? But can you tell me where k is going from? K goes from where to where? The last number is clear, so the upper limit is not n, is n minus 1. But what is the lowest limit? K should be 0, yes? So k starts from 0, and then n goes to infinity. Yes? So I have this situation. But the problem is that, of course, I can write it in this form. That's actually a very nice combination because I need 1 over n in the formula, I have it. And then you know that you can also write in a way that k over n appears. How? So I can write it as the limit 1 over n, sigma k goes from 0 to n minus 1, e to the power of k over n. N goes to infinity. So it seems everything is ready, yes, because 1 over n I have, and then I want a function of k over n I have. So the function that you guess is what? E to the power of x. Yes, but there is one problem, unfortunately, and that is the limit doesn't match. The limits in this problem should go from 1 to n, and that goes from 0 to n minus 1. Okay? So we have to pay a price. I have to fine-tune the limits. So what I do, this is a trick that I want you to learn. This is a very, very simple trick, of course. So I would write 1 over n. I add 1 unit to the limits. I start it from 1 up to n rather than 0 to n minus 1. But the price that I have to pay is to subtract 1 unit from the counter inside the sigma. Yes, so this becomes e to the power of k minus 1 over n. Okay, why is that? Because you know, for example, if I give you a sigma I goes from 1 to 3, what do you write? You write a1 plus a2 plus a3. This is the meaning of sigma. Okay, now let us assume that I add 1 unit to the lower limit. Instead of starting it from 1, I start from 2. And I add 1 unit to the upper limit. Instead of ending at 3, I end at 4. But then I subtract 1 unit from the counter inside the sigma. So instead of writing I write I minus 1. So this minus 1 that I write here will compensate for my addition to these limits. Why? Because if I ask you to expand this sigma, what do? You go, instead of I, you put 2. But because this is I minus 1, it becomes automatically a 1 again. And then after 2, it is 3. You put, instead of I, you put 3, it becomes a sub 2. And that is exactly a sub 2. And then the next one becomes a sub 3. So you see that if I add 1 unit to the limits, but I am subtracting the same unit from the counter in the sigma, I am writing it in a different way, but I am not affecting the result. First of all, I want to make sure that you understand what is going on. Is that clear? Happy? Yes? Yes? Why are we doing this? No, because I want to fix these limits. Yes, because in here everything is okay, except that I have the wrong limits for my sigma. Because if I want to use a theorem in mathematics, it should be exactly to the rules should the conditions should be exactly the conditions of the theorem. Yes, but then of course I made a problem for myself, because instead of having k over n, which was a good thing, now I have k minus 1 over n, which is a bad thing. Okay, so it seems that I am in a loop. Yes, fixing one thing will ruin the other one, and vice versa. But the point is that this Riemann sum is not this Riemann sum, but that's also another Riemann sum. Okay, that I want you to understand this point. So n goes to infinity. So what is your guess about the interval here? Do you have any guess about the interval for this Riemann sum again? Let us not change the 0 and 1 for the time being. And then let me have a regular partition for the interval from 0 to 1. Okay? So what is my goal? My goal is to convince you that this sum that you see here is, of course, not this sum, but this is also a Riemann sum. Because do you remember, for any given interval and any given partition, I have infinitely many degrees of freedom, which I call them tags. Yes, that is under my control. I can change the tags. Yes, so let us just try to understand why this is also another Riemann sum. So if I take the regular partition for this to n parts, then you hopefully agree with me again that the delta x is still 1 over n. So far so good, because I have 1 over n and delta x is there. But if I ask you what is the kth interval, how do you answer that? Do you remember the kth interval is what? Is equal to x sub k minus 1 and x sub k. If I ask you what is x sub k, do you remember it was the first number, which is 0, plus k times delta x, which is k times over n. So what happens? This means that this becomes equal. Instead of x sub k minus 1, I replace k with k minus 1, it becomes this. And then instead of x sub k, I write k over n. So if I ask you, what is the kth interval for this partition, you show me this. Okay? And now look, what is happening here? This k minus 1 is also a tag. Yes? In the previous Riemann sum, k over n was chosen as my tag. What is the tag? Do you remember? A number, any number that you like, in the kth interval is called the kth tag. That in the previous lesson, I represented it by c sub k. Yes? This is a Riemann sum, but in this Riemann sum, k over n, which is the last point of the interval, is chosen to be the tag. But it doesn't matter. In this scenario, k minus 1 over n, which is still within the same interval, has chosen to be a tag. Understandable or not? Okay, so this means that, okay, now if you understand, by the way, what is the function here? If you introduce the function as you mentioned, f of x to be what? E to power x, then what I can write this limit is the limit of sigma k goes from 1 to n. Instead of this expression, I can write in my head f of k minus 1 over n, and instead of 1 over n, I flip it inside, but 1 over n is delta x. So do you see, this is the Riemann sum, and n goes to infinity. In this case, this number is my tag, ck. Now don't look inside and read it. It becomes the limit of sigma f c sub k delta x, so that c sub k is a point in the kth interval. That's exactly the meaning of the Riemann sum. Understandable? Yes or no? Yes?
Why is the tag ck not ck minus 1?
No, you can choose anything. But the point is that if you want to solve a limit using integral, first you have to convince yourself that the limit is the limit of a Riemann sum. Which Riemann sum, we don't know. It depends on the person who had designed the question. Yes? But the only thing is that try to convince yourself that what is asked here is a Riemann sum. Okay? As soon as you understand that is a Riemann sum for a function on an interval with some particular choices of tags, then it means that instead of calculating the limit of the Riemann sum, instead you can calculate the corresponding integral. This is the logic. It's a little bit convoluted, but if you practice, you will learn. It's not that hard. But I want you to follow the logic, so by more examples, you will try to learn how to do it, okay? But is there something that you don't understand here? So because there are two types of questions in mathematics. One question is that when I explain, you don't understand. Another question is that you're always asking yourself, how could this come to my mind? Okay, that is the second scenario. You first of all, you need to learn what I am telling to you, and the next one comes after practicing a lot. Okay, but this one, only for this problem, do you have any misunderstanding or something that you don't understand? Okay, if you understand, tell me what is the answer then. Yes? What is the answer to this limit now? What is the limit? No, so it means that if you hesitate, it means that you don't understand. Let me ask you one thing. If I ask you, give me a name for this sum, what do you say? Okay, just read it, okay, in English sentence. What is this sum? What is the name of this sum in mathematics? It's not complete. It is the Riemann sum, it continues. It is the Riemann sum of, it is the Riemann sum corresponding to this function, yes, and this interval with a regular partition, so that the tags are chosen to be the left end points of subintervals. Something like this, yes? So that is the Riemann sum. And if that is the case, the limit of a Riemann sum, if my function is integrable, is equal, can be interpreted as an integral. But first of all, is my function integrable? Yes, because the exponential function is continuous. Continuity implies integrability, so I am on the safe side. But then again, can you write something in front of it? Which integral? It shouldn't be hard. It's the integral of your function. What is your function? E to power x dx. On an interval. On which interval? On the interval that you work with that interval. What was that interval? 0 to 1. So I want you to understand that this is exactly 0 to 1 e to power of x dx. But I want you to see here it was k over n. The answer was this. But again, k minus 1 over n, the answer is again that one. Is that understandable? Because that's also a Riemann sum. That Riemann sum is a Riemann sum where the tags are the endpoints. This one is a Riemann sum where the tags are the initial points. Yes? Understandable or not? Okay, we can make more examples, but this is very easy to calculate now. Why? Because the primitive function is this. From 0 to 1, it becomes e minus e to power 0, which is e minus 1. So the answer to this is e minus 1. Yes? Yeah? Okay, but for this one, we have another method. I don't know. Do you know how to do that? For example, in this case, we can just completely do it in a different way, but that is a special case. Because if you can interpret this in this way, instead of 1, I write 1. Instead of a square nth root of e, I write e to power 1 over n. And then the next one, e to power 2 over n. And this continues plus e to power n minus 1n. Yes, and this becomes a sum for me. But we will study this later. But this you have studied in high school, I think. There is a name for this sum. What is the name of this sum? You have that in high school. You had it in high school. What type of sum is that? There are two sums that you have studied in high school. One of them is arithmetic progression. The other one is a geometric progression. Yes? Arithmetic progression is that every term is obtained from the previous term by adding a constant. Geometric progression is a sequence, is a series, so that every term is obtained from the previous one by multiplying by a constant. But what is that constant here? That constant is e to power 1 over n. If I take 1 and multiply it by e to power 1 over n, it generates the next term. If I take this term and multiply it by e to power 1 over n, it generates the second term, yes? If I take this one and multiply it by e to power 1 over n, it generates the next one. Do you agree? So every time I am multiplying by e to power 1 over n, getting the next term. So that's the geometric sum. So this is a geometric sum. And a geometric sum has a formula. So this is the sum of n terms, which is called S sub n. So the sum of the first n terms. So there is a formula for Sn. Sn is the first term. So let me write T1 times 1 minus the common ratio, this fixed number that I am multiplying by each term to generate the next term is called the common ratio, to the power of n divided by 1 minus r. We will study that in the 7th module again, but this is something from high school. In this course, we study infinite series, yes, which continue forever, but that's the geometric sum. So the geometric progression, it means that it ends at somewhere. Okay, so if I use this formula to find this sum, the first term is 1 minus r. What was r? R is this constant that I am always multiplying. So it is e to power 1 over n, and then I have to power n. And then divided by 1 minus r, which is this one. Okay, let us simplify that. It becomes e, so it becomes 1 minus e divided by 1 minus e to power 1 over n. Yes? Okay, and then I go back to my question mark. So my question mark is 1 over n times that. So it is 1 minus e, sorry, the limit of 1 minus e over n times 1 minus e to power 1 over n. N goes to infinity. So that is a completely different way. Here I use the Riemann sum to calculate that limit, but this is one of those cases that you asked me last time. We can have another method to solve it, yes? And this, I will leave as an exercise. If you calculate this limit, in principle, it shouldn't be hard for you at this level, that if you calculate this limit, by the way, what type of limit is that when I put n equals to infinity? 1 over infinity, 0 e to power 0, 1, 1 minus 1, 0, 0 times infinity. So that is indeterminate form. If you calculate this limit, it becomes minus 1. I ask you to do it yourself. And if that is the case, then it means that the limit becomes this divided by minus 1, which you get exactly the same answer that you got using a completely different method. Okay, the reason that we could solve it in a different way, because it was a coincidence. We had a formula to find a formula for the sum, but here we don't have any formula to find the sum. Okay, is that understandable? Okay, let me give you another example, or let us solve this exam problem from the previous session. So this is exam 2019. This is a good example, I would say. And 22 Q5. Question number 5. So this is asked. You are supposed to calculate the limit of this expression. Sigma k goes from 1 to n, 2 over n plus 2 over n, and square root of 2k over n. N goes to infinity. We are supposed to calculate this limit, and then after that there is another part for this problem which is not related to this, but that's also important to know. So let us concentrate on calculating this limit. Okay, I hope that you agree with me. This is somehow related to what we are talking here. Yes, if I want to use this trick to solve that problem, I have to convince myself that this is a Riemann sum of a function on an interval. So that is up to me to guess that function and to guess the corresponding interval, to motivate that this is indeed a Riemann sum. So that is the hard part. As soon as you just understood what type of Riemann sum is, then it becomes actually very easy. Okay, so I have to erase it. Okay, so do you have any ideas? So let me write it here again. So the limit of 2 over n plus 2 over n, square root of 2k over n, n goes to infinity. Any ideas? Yes? I don't know, because when I read the solution by the examiner, he was thinking that he's making it in a different interval. But I was able to prove it, to solve it using this original formula. So let us solve it using this original formula here. Yes, so I will take, so first of all, I will take 2 over n out, as you said. Oh, I missed a sigma, yes? So there is a sigma involved here, sorry. K goes from 1 to n. So what I do, I take 2 over n out, yes? So this becomes sigma. This becomes 1 plus, I took this away, so this becomes square root of 2 times k over n, yes? And k goes from 1 to n. The examiner writes that this 2 motivates you to look at this interval, yes? Rather than the interval from 0 to 1, because you see that 2 appears in the numerator. But then if you want to interpret it in that way, I will solve it in that way as well, because that is actually instructive. But you are making life harder for yourself, because this 2, it doesn't have any problem, doesn't make any problem for me, yes? Because 2 is a constant, I can pull it out from the limit as well, yes? So what happens, this becomes 2, the limit of 1 over n sigma k goes from 1 to n 1 plus a square root of 2 times k over n. N goes to infinity. So you see, this doesn't impose any problems for me. I just need to calculate this limit, and then whatever it happens, I multiply it by 2. Okay, but now let us compare it with that limit, and then you immediately can guess what's happening. The formula, the standard Riemann sum, or the famous Riemann sum, which is usually used, is this Riemann sum. Just compare your limit with this standard Riemann. I don't know if it is good to call it a standard, but this is ubiquitous Riemann sum. Okay, so can you guess what your function is? You see, everything you need is there. 1 over n sigma with the appropriate limit, k1 to n, k1 to n. Yes, and then you should be able to guess your function. What function is involved in this problem? F of x is what? Is a square root of, no, sorry, is what? 1 plus the square root of 2x. Yes, this is the function. Because I told you that as soon as you can have your sigma of this 4, k over n actually plays the role of your x. Yes? Okay, so now there is one question that you have to address. Is this function integrable? The answer is yes. On which interval you are working? You are working on which interval? Remember, this formula is always on this interval. Yes? So you are working on the interval from 0 to 1, and this function is continuous. Consequently, it is integrable. So everything is good. So this means that this limit is the integral from 0 to 1, the function that you guessed, dx, but there is also a factor of 2 before the limit, so I have to multiply an extra 2 here. Is that understandable? Okay, so now we have to calculate this integral. Let me just do this because I want to compare it with a different result. So a primitive function for 1 is x, and this square root of 2x can be viewed as a square root of 2, which is just a constant, times the square root of x, square root of 2x to the power of 1/2. So I find a primitive function for this. So this becomes a square root of 2. A primitive function for this function is 2/3 x to the power of 2/3. Sorry, 3/3, 3 over 2. And then this should be calculated between 0 and 1. I put 1 and then I put 0. 0 doesn't matter, it becomes 0, so I put 1. So the answer becomes 2. Instead of x and x, I put 1. So the answer becomes 1 plus 2 square root of 2 divided by 3. I multiply this 2 in, so it becomes 2, 4 square root of 2 over 3. So that is the limit. Yes? But now, let us solve it in the way that the examiner was expecting. Okay? He writes probably that because you see 2 over n, don't work on this interval, okay? So work on the interval from 0 to 2. Why is that? Because I told you that what is delta x? Delta x is the final number. If you are working on the interval a and b, for a regular partition, delta x is b minus a over n. So if a is 0 and b is 2, then it becomes 2 minus 0 over n, which will give you the factor of 2 over n that you need. Okay? So in that case, what you do again for answering the question mark, this becomes the limit. I factor a 2 over n out as before, okay? K goes from 1 to n, then I will have 1 plus square root of 2k over n. Okay, and then n goes to infinity. Or might be, if you don't mind, let me don't pull 2n out here. Let me put 2n here. Pull it out and put it here. Yes? Okay, now this is playing the role. Do you remember the form of the Riemann sum? The form of the Riemann sum is a function that you have to guess, calculated at c sub k, which is a tag that you have to guess, times delta x. Yes, this is the form of a Riemann sum. So you have to do your guess. Of course, immediately you realize this is your delta x part. So there is two duties on you: finding the function and finding the tag. Okay, So if I want to find a tag, I need to know the kth interval. Why? Because ck is a number in the kth interval. So I have to know that kth interval first. How should I know that? Okay, let us do that. Do you remember, for finding the kth interval, what you need to do is to calculate xk first, which is a, the initial number, plus how many times k times your delta x. Yes? This is the formula for x sub k. I start from a. When I want to reach to the kth point, I have to add k times of these lengths of each subinterval. Okay? So, but a in this problem is 0 again. Okay? Because I want to work on this interval 0 and 2. K is k, but what is this one? It is 2 over n. And when I multiply it, it becomes 2k over n, which is 2k over n. And now I ask you, what is the kth interval? The kth interval is always what? X sub k minus 1 to x sub k. But what is x sub k minus 1? This is x sub k, so I go there and replace k with k minus 1. When I multiply 2 in, it becomes 2k minus 2 divided by n. And what is x sub k is exactly 2k over n. Okay, now my question for you is that, what tag do you see here? This is supposed to be your tag. Yes? Is this tag really an acceptable tag in this scenario? Yes or no? Is this is supposed to be, because this is supposed to be f of your ck. Do you agree? Your goal is to interpret this as f of some ck so that you can have your Riemann sum. Okay? In that case, you want, if possible, to give the role of the tag to 2k over n. But can you give the role of the tag to 2k over n? The answer is yes, because 2k over n lies in the kth interval. Understandable? Any point in that interval. So this means that yes, this is a Riemann sum. So can you tell me now your function? So this exactly plays the role of my tag here. Can you give me the function? What is f of x in this case? Don't make mistake. What is that? 1 plus x, the square root of x. In the previous one, the function that you have to guess was 1 plus the square root of 2x. Okay? But in this case, you see that you should guess this function. Okay, now my question is that, is this limit equal to an integral? The answer is yes, because this function is integrable on that interval from 0 to 2. So, but can you tell me now, what happens at the end? The limit that I am looking for is an integral, of course. You need to tell me that, okay, this is a continuous function on that interval, so that's integrable, and that is a Riemann sum. The limit of every Riemann sum becomes equal to the integral. Integral of which function from where to where? Which function? This function that I guessed. From where to where? This time from 0 to 2. Okay? But if you calculate this integral, this becomes x. This becomes 2/3 x to the power of 3 over 2, but from 0 to 2. I put 2 here, it becomes 2 plus 2 over 3. 2 to the power of 3 over 2 is 2 square root of 2. And if I put 0, it is 0. So the answer becomes 2 plus 4 square root of 2 over 3. And that's exactly the number that I got from the previous calculation. So you see that this is one example that I could interpret it in two different ways as Riemann sums. As a Riemann sum for this function on that interval from 0 to 2, or as a 2 times a Riemann sum of a function, this function, and the interval 0 and 1. So I agree, this is a little bit hard, but it is not very hard. If you understand what is going on, you have to be able to calculate that. So if you don't mind, before going to the next part of this problem of the exam, I will come back and solve it. So now that you are understanding, let me give you another example, and then I think that would be enough. Okay? So we want to calculate, this is a problem in atoms, yes? So we want to calculate this limit. K goes from 1 to n. The third root of 1 plus 2k minus 1 over n. N goes to infinity. This is a problem in your course book. You want to calculate this limit. This is probably a little bit hard. I don't know. Do you have any guess for your interval? Because you should have some, at least a rough guess about your interval. Because everything is on the board now, we are not in trouble, okay? So, yes, let me bring this board a little bit lower so that it also be in the frame when we are recording. Yes. So do you remember, by the way, don't forget these forms. In the exam, it is good to have some memory about what you have done before, yes? If my interval is from 0 to 1, and I only look at the regular partition, this is always the case. The kth interval is like this. Because it doesn't matter, you see, I give you the interval, you divide it into n equal pieces, and I ask you to calculate the kth interval or determine the kth interval. You do that and you get this one. So remember this form. It is always the kth interval for the regular partition of the interval from 0 to 1. Yes? Okay, do you think that you can interpret this? Because what you need to interpret this part should be f of some tag. But where this tag is, the tag should be in the kth interval. And that is up to you to start engineering the problem, okay? That is up to you, okay? If you say that interval is from 0 to 1, then you should have a guess for your tag and a guess for your function. Guessing the function is not hard. What is the idea about your function? Do you have any guess for the function involved in this problem? Because you see a third root, yes, and then you see a constant, yes, and if, there is no guarantee yet, if that part can be a tag ck, then I am done. Because then the function involved becomes the third root of 1 plus x, if I can do that. But do you think that this tag lies in this interval? Do you think that this tag lies in this interval? Yes or no? What is the meaning of this question? The meaning of this question is that, do you think that this is guaranteed that this number is in this interval? It means that, do you think it is guaranteed that this is always a smaller than or equal to kn and greater than or equal to k minus 1 over n? I don't think so. No, I don't, because let us check. This n and this n are the same. If you say that is the case, it means that you are claiming that 2k minus 1 always and always is less than or equal to k, which is not true. Yes? 2k minus 1 is not always less than or equal to k. Is that clear? Because 2k minus 1 is actually larger than k. Okay? Unless k is less than 1, which is not possible. Okay, so this means that this is not working. Okay, so then what? So it means that I have to change my interval, because if I choose my interval from 0 to 1, this is the only subinterval that I can get, and that subinterval does not work. Yes? Okay, so can you tell me what interval will work? Still, we have it on the board. You see here? if the interval is from 0 to 2, this is the kth subinterval. Now my question for you is that, do you think that 2k minus 1 over n lies in the kth interval in this case? Meaning that, do you think this is true or false all the time? True or false? This is true, yes? Because the denominators are all the same. This is 2k minus 2, this is 2k minus 1, and this is 2k. So that's always the case. So this means that you have to understand that working with the interval from 0 to 1 is useless for this problem. So you have to change your strategy to 0 and 2. In the previous problem, I was able to find a way to still work with 0 and 1. But in this case, it is not possible. Understandable? So then you have to work with 0 and 2. Okay. But if you work with 0 and 2, you have one small problem. The problem is that instead of 1 over n, what do you need? If you work from 0 to 2, instead of what over n, what do you need? 2 over n. But that is a minor problem because I multiply by 2 and then divide by 2. It's a constant, yes? So what happens is that, what I am saying is that this becomes, the question mark becomes 1 over 2, the limit, this becomes 2 over n, and I move it to the sigma. So this becomes sigma k from 1 to n, the third root of 1 plus ck. What is ck? This is exactly, I chosen to be my tag, and then 2 over n, which is my delta x. Because when I multiply it by 2, it becomes 2 over n. 2 over n is my delta x. So I put it here, delta x, and I divide by 2. Hopefully this is understandable for you. Yes? And now can you tell me, if you understood it correctly, what should I write? This is 1 over 2. This is a Riemann sum. But the Riemann sum of which function? The guess was easy. The third root of 1 plus x dx. What is my interval? From 0 to 2. So I consider this one a hard problem. So I want you to feel that in this case, the interval 0 to 1 was not enough. Yes? Delta x is 2 over n. Yes? So this was 1 over n. If I want to make it clear, what I did, instead of 1 over n, I wrote 2 over n, but I multiplied by 1 over 2 here. Then I moved 2 over n inside, but instead of 2 over n, I wrote delta x because I want to make the Riemann sum manifest itself here. And this becomes that integral. Agree? Yes? And so if I can calculate this integral, I am done. But let us do this practice. What is your suggestion? How do you calculate this integral? Can you tell me? So let me write it once more and calculate it for us. So what is your suggestion for calculating this integral? Any ideas? Substitution, yes? So what I would take the third root of 1 plus x to be u. But before differentiation, do you remember my trick? I told you raise it to power 3 and then differentiate. So this becomes 1 plus x is u to power 3. If you don't do that, that also, if you just take this one to be u, that will also work, but this is better. I take the derivative from both sides. The derivative of is 1 multiplied by dx. The derivative on the right-hand side is 3u squared du. And then this becomes equal to 1 over 2, but I have to change the limits. If x is 0, u is the third root of 1, which is 1. If x is 2, u is the third root of 3. And then instead of this expression, I just simply put u, and instead of dx, I put 3u squared du. And this is easy to solve, yes? Because 3 goes out, it becomes 3 over 2, integral from 1 to third root of 2, and this becomes u to the power of 3 du, but u to power 3 is 1/4 of u to power 4, so this becomes 3/8 u to power 4, and it goes from 1 to the third root of 2. And if you simplify this a little bit, it becomes the third root of 16 minus 1. So that number is the limit, actually. Okay? To make sure that you understand this problem, I want to write one exercise for you that is also a problem in atoms. If you can solve this one, it means that you are completely on the safe side. You really understood this problem, okay? So I want to write this down. I will not solve it here for you. We don't have time, but I will come back to it if you need help. So the limit of, let me write arctangent of there should be a sigma involved. Sigma I goes from 1 to n, and then arctangent of 2i minus 1, but this time, instead of dividing by n, I divide by 2n, and I send n to infinity. If you really can write this, if you can interpret this as an appropriate Riemann sum, it means that you really understood what is going on. And the point is that if the problem or if the guess is so complicated, even I myself cannot guess. That is not the point. The point is to understand how you can solve the normal problems, okay? So if you can solve that problem, interpret this as a Riemann sum of a function, and you find the interval, it means that you are completely done with this problem, okay? Okay, so I will go back to that exam problem and solve the second part. That's also good. Then we go to the next module eventually, okay? Any questions? Okay, so if you want to take a photo, you can take it so that I can clean the board. Okay, so the second part of this exam problem is also a good problem because that's also somehow related to what we want to talk in this new module. You want to calculate this limit. First of all, I want you to have a good understanding about the problem. You see, n is a natural number. For example, if I give you n equal to 1, then you put 1 here, it becomes integral from 1 to 2. You calculate it. Of course, in this case, it is not possible to calculate it because you do not have any primitive function for this case. But then at the end, it becomes a number. Okay? This gives you a number. When I put n equals to 1, in principle, this integral becomes a number. Then I change n from 1 to 2. This becomes from 2 to 3. Then it becomes a new integral. If you calculate it, it becomes a number. So you see that this integral defines a sequence of numbers. And then you are asking, what is the limit of this sequence of numbers? Okay, so you have to view the problem in this way. And of course, if this function is a function so that you can integrate it easily, the answer to this question probably is not hard at all. For example, if I just ask you to calculate the limit of integral from n to n plus 1, but I give you this function. This problem I consider a very simple problem. Let me make it better. So this is a little bit problematic. Or no, that's good. For example, if I ask you what is the limit of this? In this case, you can calculate the integral first. How? This is a famous function, 1 over t. What is the primitive function for that? Is ln of absolute value t, and it goes from n to n plus 1. Yes? If I ask you what is this, you would tell me this is the answer to this integral. And from this answer, I have to take the limit and send n to infinity. Yes? Let us calculate this. I have to put n plus 1 there. So this becomes ln of absolute value of n plus 1. But because n plus 1 is positive, n is a natural number, I don't need absolute value at all. This one. And the same story for the next one. So this becomes this. Yes? And then you got rid of this integral. You focus on calculating the limit of this sequence. Okay? So how you can calculate it, for example, you can say that this is the limit of ln of n plus 1 divided by n. Do you agree? And n goes to infinity. But you can divide n over n. So this becomes what? ln of 1 plus 1 over n. N goes to infinity. So this part becomes 0. So the answer becomes ln of 1. The answer becomes 0. So the limit of this is 0. But this method will not work for that because I cannot calculate the integral. That's the whole point. Yes, this is one of those functions. Of course, if I don't know, but I think my impression is that finding a primitive function for this probably is not among the elementary functions. So that is the main difference between this problem and that problem, but essentially they are the same problems. Yes? Now the question is that even though we cannot calculate the integral so that we cannot follow this strategy, we still want to calculate the limit. Is the problem clear now? What is the problem here? So we want to do the same thing, but without doing this. Why? Because we cannot do this. We cannot calculate the integral here like before so that then I can calculate the limit. Yes? So what we should do for these kinds of problems, there is only one trick, and that is probably squeezing theorem. So you need to restrict your sequence between two sequences and be lucky so that the limit of the right-hand sequence and the limit of the left-hand sequence be exactly the same. Then you can conclude the limit of the sequence in the middle is also the same number. And it is extremely hard sometimes. Okay? So first of all, so let us just skip this one. At least you understand the problem in principle is not hard. The hardness of this problem is because we cannot calculate. We need to find a way to go around this problem, okay? Okay, so but let me do it step by step. One thing that I want you to know, if you are working on an interval a and b, and you have two functions f and g, if you know that on that particular interval, f of x is always less than or equal to g of x, and if you know that these functions are integrable on that interval, so then you can conclude that, so for all x in this, f of x is less than or equal to g of x, you can conclude that the integral from a to b, f of x dx, is also less than or equal to the integral from a to b, g of x dx. Yes? This is something that we also need in this module. Okay, now let us try to see how it works for this case. I start from integral from n to n plus 1 and t times sine of 1 over t dt. I write something and I ask your opinion about that. I write that this is definitely less than or equal to integral from n to n plus 1, n plus 1 multiplied by sine of 1 over t dt. Do you buy what I want to sell to you? Do you agree that this is correct? If you agree, why? I am claiming that this integral, which is given in the problem, is definitely less than or at most equal to this integral that I just wrote it myself. Why is that the case? Yes? Okay, more. Okay, why this is the case? The reason is that compare this function with this function that I have written here. Give the role of f to this function, give the role of g to this function, okay? Which one is bigger than the other one? You see, if I ask you what is the maximum value of t, because t goes in this interval, the highest value that t can achieve is n plus 1. Yes? And sine of 1 over t is a positive number in this case. Why? Because t is between n and n plus 1. So this means that 1 over t is greater than or equal 1 over n plus 1 and less than 1 over 1 over n. But 1 over n plus 1 is positive. 1 over n is less than or equal to 1, and 1 is less than pi over 2. Yes? So I convinced you, hopefully, that this angle, which sits in front of sine, is a positive number, smaller than pi over 2. So this means that this angle, if you can call it the argument of sine, is in the first quadrant. And in the first quadrant, sine is positive. Yes? So this part is positive, and this is at most equal to n plus 1. So hopefully you agree with me, this function f is always less than or equal to this function g. Yes or no? Agree? But I want to go one more. I could do it in one step, but I think this is easier for you to understand. I still want to continue and write integral from n to n plus 1, and I write n plus 1. I want to write sine, instead of 1t, I write 1 over n dt. Do you agree with this one as well? What I am doing, I am comparing this function with this function, let me call it h. Which, do you agree that function g is less than or equal than function h? Why? Because the n plus 1 parts are the same. I haven't changed anything. So, but I am claiming that sine of 1 over t is smaller than sine of 1 over n. Do you agree? Why is that? Because you see, 1 over t is smaller than 1 over n, and I am in the first quadrant. So I have two angles, 1 over t and 1 over n, but this angle is smaller. When the angle is smaller in the first quadrant, the sine is also smaller. Yes? Because the sine is the y coordinate. When the angle becomes smaller, the y coordinate also becomes smaller. Agree? So this means that sine of 1 over t is definitely smaller than sine of 1 over n. Agree? Okay. And then, can I pull this out? The answer is yes, because this does not depend on the variable of integral. The variable of integral is t. This is just a constant. So I pull it out. So from now on, it is equal. This becomes n plus 1, sine of 1 over n. What is left is the integral from n to n plus 1, and then dt. Yes? Okay, now can you calculate the integral immediately? 3 seconds. What's the answer? No, the whole integral. Yes, that is t, the whole integral. 1, because t, you are right, the answer becomes t from n to n plus 1. So the answer becomes 1. Agree? So this is just 1. So this means that I showed that this integral, so let me write it here. Integral from n to n plus 1, t sine 1 over t dt is less than or equal n plus 1 sine 1 over n. Agree? I was not able to calculate the integral, but I did some estimation for my integral. I proved that whatever this number is, it is always less than or equal to this number. Okay? Yes? No, the integral of dt means this function, this number here, I am asking you give me a function whose derivative with respect to t is 1, so it becomes t. And then whenever you have this, you have to calculate it between this. You need to replace t with n plus 1, replace t with n, and then subtract them. So it becomes n plus 1 minus n, which is 1. Okay, but I hope that you agree with me. This argument can go also to the left. Do you agree with me? So if you understand what is going on, now, can you tell me how should make this bigger? Okay, so n plus 1, I hope that you understand what is going on. Can you help me to write it? This time, I want to I want to prove that this integral is bigger than another number. Can you tell me how should I reach to that number? If you understand this process, you can also write something for this. This time, you want to write something here so that this integral is bigger than that one. Can you tell me the first step? Yes? No, first of all, tell me about t. What should I write? No? So do you remember what I did here? The same idea. N. Thank you. Why? So let me write first. Oh, sorry, this is t. Might be I confuse you because of this. This is t. Sine of 1 over t dt. Let me again repeat. Let me call this function f and this function g. Do you agree that function f is larger than function g? Yes, because I kept this part the same, and instead of t, I wrote n. But this is clear that t is larger than n because t is between n and n plus 1. So the lowest value of t is n. So this one is definitely bigger than that one. Yes? But I can continue the same with the same idea. Can you tell me what I will do next? I will repeat this n, but what will I write for sine? Instead of 1 over t, I write what? And then dt. 1 over n plus 1. Yes? Do you agree? Because if I call this function h, do you agree that function g is larger than function h? Why? Because the n parts are exactly the same. What I am telling you is that sine of 1 over t is greater than sine of 1 over n plus 1. That is correct because 1 over t itself is greater than 1 over n plus 1. So the sine of this one is also greater than the sine of that one. Okay, but then what is the answer to this integral? I can pull this number out, and then the integral from n to n plus 1 dt is left, but again, the same scenario, this is 1. So this becomes n times sine 1 n plus 1. Yes? So at the end, what I got this integral from n to n plus 1 t sine of 1 over t dt is less than or equal to, what was that? N plus 1 sine of 1 over n, and then n sine of 1 over n plus 1. This is what I found. I was not able to calculate that number, which is that integral, but I was able to show that whatever this number is, definitely it is smaller than that number, and definitely it is larger than this number. So that sequence is now squeezed between two sequences. And of course, that is the annoying part. Sometimes you do all the work, but then unfortunately, the limit of these two sequences are not the same, so everything is gone. Okay? So you cannot draw any conclusions. So be careful. If the limits are not the same, you cannot say anything. But if the limits are the same, then the limit of the middle one is also equal to that number. But then this will motivate me to start calculating the limit of that and the limit of this. So now I want you to help me to do that. Do you have any idea how to calculate this limit when n goes to infinity? You can use the squeezing theorem again, you mean? So how? Mm-hmm. So n plus 1, let me use your idea because I wanted to do another thing, but now I think yours better. So this n plus 1 sign, this is, do you agree this is always less than? Okay, but you need to know a theorem for that. That's why I wanted to avoid that. Because this is correct. Because the reason is that if you see, we had this in one part of my lesson, that sine of 1 over n, sine of any angle is less than or equal to the angle itself. So if you use this, that is working and that is very nice. But if you don't know that, but still you can solve this, how? Let me just ignore this method. But this is the best way, I think. Because this, then on the other hand, so you write it like this, absolute value of this is less than this one, and the limit of this is actually equal to 1. Yeah, so this means something like this. But it doesn't work in that case. No, it doesn't work in this way. But it should. Okay, anyway. So let me clean this. I'm sure that this should work as well. But let me just solve this integral, for this limit for you. It's not hard, by the way. So what you do, you multiply this in, so it becomes n sine of 1 over n, and then plus sine of 1 over n. Okay? Let me go a little bit faster this time. So can you tell me what is the limit of this part? Just quickly, what's the answer? 0, because 1 over, okay, that's 0. But this one is a little bit problematic. What is the limit of this one? What? You said 1? Yeah, that's correct. Why? The limit of this one is 1 because you can write it in this way. You can write it as the limit of sine of 1 over n over 1 over n. N goes to infinity. Yes? Because 1 over n becomes n. But do you remember, if I take this one to be my box, then n goes to infinity, the box goes where? To 0. And that's a famous theorem. Sine of an angle divided by that angle when the angle goes to 0 is actually 1. Yes? So we were able to show that the limit of this part is 1. So this approaches to 1. In the same way, you can convince yourself that this one also goes to 1. How? The limit of n times sine of 1 over n plus 1. How do you write it this time? You can write it as sine. You can write it as n plus 1 sine of 1 over n plus 1, but this time minus sine of 1 over n plus 1. Yes, is that understandable? If I multiply this n, it becomes n sine 1 over n plus 1, which is my function, my sequence. And there is an extra term that I brought this in. I have to take it away to compensate for that addition. Yes? But now again, the same story. If I ask you what is the limit of this part, what is the answer? 0. This can be written exactly the same way. Sine of 1 over n plus 1 divided by 1 over n plus 1. Yes? The same story. The limit n goes to infinity. This time you can take this to be your box. The box, this time box goes to 0 again. The limit becomes 1. So the limit of the left and the limit of the right are both equal to 1. And then, so this means that the limit of the sequence in the middle is also 1. So that is a very hard problem because that's just the second part of the problem with the Riemann sum. Okay? But I hope that you understand, because these kinds of arguments is also needed in this module. So eventually we are ready to go to this new module now, okay? So let me motivate you why this is the case, that we need this topic. So that is the improper, or sometimes I have heard they say generalized integrals. What they mean by this? Do you remember when I started talking about integrability, one property of the function I mentioned, what was that? The function was bounded, yes? And the interval was a closed interval, which is also bounded, okay? So when you want to talk about proper integrals, as we did before, I started with the function. The constraint for f was that the function should be bounded, and the interval of integration was a closed, bounded interval. Yes, it doesn't go to infinity. So it was a line segment. Yes, not from a point to infinity or from a point to negative infinity. That was just an interval, a finite, a bounded interval. Okay, so we had this one bounded, this one bounded, bounded and closed. Okay, so if I relax these conditions, then I face improper integrals. Yes, so it means that I have two types of improper integrals. One type, I relax this condition, and one other type, I relax this condition. Then I can have also a mixture of them. Yes, so in principle, we have two types. Type 1, what is the type 1? I would write that A is in minus infinity, or b is positive infinity, or both. Yes, in this case, I say type 1 improper integral. Yes, if my interval has this form, integral from minus infinity to b, or integral from a to positive infinity, or the integral from minus infinity to positive infinity. So you see that the interval is not bounded. Okay, and then I can have three scenarios. Each one of them, you can call it type 1 improper integral, because the interval is an unbounded interval. Yes, but another type is that you can keep your interval bounded, but you can make your function unbounded. Yes, for example, so let me write type 2. A, B are finite, but F is not bounded on the interval from A to B. Yes? For example, if I give you this interval minus 1 and 1, everyone knows that this interval is bounded. It is limited between minus 1 and 1. Okay? If I consider the function f of x equals to x squared, this function on this interval is bounded. It cannot go very high, it cannot go very low. Do you agree what I mean? Do you understand what I mean? If you draw the graph of this function on this interval, it would be something like this, from minus 1 to 1. It is limited in this strip, yes? So it doesn't go high, doesn't go low, okay, it's that much. So that's a bounded function here. But consider the same scenario, but this time I change my function to g of x equals to 1 over x. This is bounded, but this function is not bounded on that interval, because if you draw the graph of this function, x equals to 0 is a vertical asymptote for this function. So this function goes like this. You see, from minus 1, I am here up to here. So you see, in this interval, I cannot limit the graph of the function, because this function from here goes up to infinity, and from here it goes up to minus infinity. So it is not bounded. Even though the interval is still bounded, the function is not bounded. Okay? So if the function is not bounded, it's not a proper integral, because what I did for the integrals was based on bounded functions, if you go back and see the notes and everything. And the interval was also bounded. So if I relax the first condition, this one, I will get type 1 integral, improper integral, which can also consider to be three cases like this. And if I relax the second condition, then I am facing another type of improper integral, which is called type 2 integrals. Yes, improper integrals. And now we want to talk about these. Okay. Now you see the definitions here. So let me just tell you. For example, what can we say about this? So assume that you have a function f, but your interval starts from a and goes to positive infinity, and f is continuous here. F is continuous. Yes, on this interval. In that case, integral from a to infinity of f of x dx is defined in this way. They tell you that instead of infinity, write a number r and calculate it from a to r. You get something in terms of r, and then at the end take the limit and send r to infinity. So that is the definition of this type of integral. Yes. So whenever you see this symbol or this notation, they mean this. And this is just a proper integral, because it goes from a number to a number. You calculate it, and then at the end take the limit and send r to positive infinity. So in principle, improper integral of this type is nothing, because you already know how to calculate this integral in principle, and then you already know how to calculate limits. So you combine these two problems, it becomes this problem. Yes? Okay. And then I think you can also guess what will happen for this case. So this we checked. What will happen for this case? F should be continuous. The interval should be from minus infinity to b. And then if you want to calculate from minus infinity to b f of x dx, how do you define it? Semicolon equals to means it defined to be. Defined to be taking the integral from r to b instead of minus infinity to b. Just calculate the integral normally. And when you finish, so you take the limit and send this time r to minus infinity. Yes? The value, okay, and then there are some terminologies I want you to know, because you know that sometimes limits exist and sometimes limits don't exist. So if the limit exists, we say that this integral converges to that value. That is the terminology is used, okay? If you calculate this limit, it turns out to be 5, then you say that this integral converges to 5, okay? And then I think we also have a constraint here. How I mentioned positiveness here. No. Okay. And if it converges, so if this limit for any reason does not exist, you say that the integral diverges. Sometimes the limit does not exist, but it does not go to infinity or negative infinity. So you just say diverges. But sometimes the limit becomes infinite itself. Then you say that it diverges to infinity. But still it diverges, okay? Even though the answer is infinite. Okay? So now it is more or less clear. The first thing, the questions that you are asked are these type of questions. They can ask you, are these integrals convergent or divergent? Okay? So you need to learn two techniques to answer them. One technique is just the definition to calculate the integral. If at the end you get a number, you say it converges, otherwise it diverges. Okay? So this example that I mentioned here is of this type. So I tell you that integral from 0 to infinity, we want to calculate this if possible. So the question is this. I don't know how they have written it from. Okay, compute the following improper integrals. Okay, so we can ask in this way. We can say that, does this integral converges or diverges? If it converges, what is the answer? Okay, something like that. Okay, so if you see this, the first thing that should come to your mind is the definition. So what you do, you take the integral from that number, which in this case is 0, but instead of writing up to infinity, you write a number r there, and then you write the integral, and then you calculate the limit of this expression when r goes to infinity. So this means that you need to copy and paste this limit part, okay? But you need to calculate this one. The hard problems are not of this type. The hard problems are the problems that you cannot calculate the integral, but still you want to show that it is divergent or convergent. And then some ideas like this becomes important, and generally they are not easy. Okay, but the exam problems are not that hard in this case. So if you want to calculate this, I think this is a famous integral for your eyes. It is arctangent of x. So this becomes arctangent of x. So don't be distracted by this part. This is just the copy-paste part. So you just focus on calculating the integral. From where to where? From 0 to r. Yes? Still, the integral is not calculated yet. I have to put r instead of x, so it becomes arctangent of r minus arctangent of 0, and then calculate this limit when r goes to infinity. But everyone knows arctangent of 0 is 0, and I want to see how many of you remember this limit. Do you know this limit? Arctangent of r when r goes to infinity. Pi over 2, thank you. So the answer becomes pi over 2. So now answer my question. Is this integral convergent or divergent? Convergent. Converges to pi over 2. Yes? So that's one. Let us do the other one. Integral from 0 to infinity, x e to the power of minus x dx. So what's your opinion about this? First of all, you don't need to think. If you are supposed to compute, so this is the only way that you can compute. You just put r there, and then x e to power minus x dx, and then focus your energy to see that if you can calculate this integral. So momentarily, this is not a limit problem. This is just a normal integration problem, yes? So can you tell me, do you remember the trick, or can you just remind yourself about the trick which is useful in this case? Integration by parts, exactly. So what I do, this one is to be better to be taken to be u, and this one to be dv, yes? So if I take that one to be u, so u is x, then immediately du becomes dx, and then e to power minus x dx is dv. So this means that v is minus e to power minus x. Okay, so the integral, so if you don't mind, let me call this integral I, but this I, because it depends on r, let me write it as I of r. So I of r is equal to uv, u times v, but do you remember, I have to calculate it from 0 to r. That is the definite version of the integration by parts. Goes from 0 to r, and then minus integral v times du. But in v, I have a negative sign, which makes this one to be positive, and e to power minus x dx from 0 to r. So this is my IR. I gave it a name, and I'm just calculating IR. At the end, I will take IR and calculate the limit. Yes. Thank you very much. Thank you very much. Okay, so yes, thank you. That is from 1 to r. Okay. Okay, so what should I do? I have to calculate this. I put r here, so it becomes minus r e to power minus r. And I put 1 here, so it becomes minus positive e to power minus 1. Yes? And then this integral is also famous, so it becomes e to the power of minus x from 1 to r. So let me simplify. This becomes 1 over e. Instead of this one, I would write minus r, and I bring this down. I am seeing a little bit ahead of myself because I want to calculate the limit. And then this one becomes minus e to the power of minus r plus e to the power of minus 1. Am I right? Yes. So at the end, this becomes 2 over e minus r e to the power of r plus 1 over e to the power of r. So this is my I of r. Do you agree? Double checking. Yeah, that's correct. And then I have to go back. So therefore, the question mark is the limit of I of r when r goes to infinity. So the answer, you can immediately tell me, what is that? This one is clear. E to power r becomes infinitely large. 1 over r is 0. But this is infinity over infinity. But which one will dominate? We had this before. The exponential function will dominate, yes? So that is also 0. And then what is left is just 2 over e. Yes? So this means that this integral converges to 2 over e. Okay, any questions? Okay, I have given you another example. I have written something here, show that this integral diverges. Okay, let us see how this will work. So the integral from 0 to infinity, and then I have x over 1 plus 2x squared dx. We want to show that this diverges. Okay, one way is of course to calculate it. Later we will learn another trick, because they can sometimes ask you to show that this diverges. You don't have to calculate the integral. But to be honest, probably if you are good in integration, one safe thing to do is to calculate the integral. Yes, because trying to find upper bounds and lower bounds are not usually easy. Of course, I haven't seen hard questions, but we will talk about those as well. But here, can you tell me how to do that? So first of all, I write my definition. So this becomes integral from 0 to r, and then I have x 1 plus 2x squared dx, and then r goes to infinity. Okay? It was a little bit unfortunate. Okay, can you think about it? What should I do to calculate, if possible, this integral? Any ideas? This is the substitution method again, yes? So I take this one to be u. So what I do, I will write this, u is equal to 1 plus 2x squared, yes? And then immediately I say du becomes 4x dx. But what I need in the numerator is just x dx. So I divide everything by 4. So this becomes x dx is equal to 1/4 of du. Yes? Okay. And then you can also change the limits, by the way, because here I have a definite integral. When I use the substitution method, I also changes the limit. I also change the limits. Yes. So what I do, I would say that x goes from 0 to r. This implies that my u goes from where to where? I put 0 instead of x, u becomes 1. I put r instead of x, u becomes 1 plus 2r squared. Yes? So that integral becomes equal to the limit of the integral. Instead of 0 to r, I write 1 to 1 plus 2r squared. In the numerator, I write 1/4 du, and in the denominator, I write u, and then I would say that r goes to infinity. But this is a famous integral, isn't it? It becomes 1/4 ln of absolute value of u, which goes from 1 to this number. Yes? And then what I do, I would replace this. I would replace u with this one, but this number is positive, so I don't need absolute value at all. Minus, I replace u with 1, but ln of 1 is 0, so I don't need to do anything. And I have to write the limit here as well. So you shouldn't be lazy to write this. They are sensitive to this. Okay, so this becomes the limit r goes to infinity. Okay, what is this limit now? The limit of 1/4 of this ln of this expression when r goes to infinity. So this becomes ln of infinity. And ln of infinity is infinity, yes? So this becomes infinity. So this integral diverges to infinity. Yes? Okay, let me also go to the next problem here. The question is that, what is your opinion about this integral? I have intentionally written a simple one. So what is your opinion about this integral? What you do, you just write this is the limit of the integral from 0 to r sine x dx, and then r goes to infinity. But the sign, the derivative, this is very simple. So this becomes the limit of r going to infinity. The integral of sine is negative cosine, and it goes from 0 to r. So this becomes the limit of 1 minus cosine of r when r goes to infinity. Agree? I put r, it becomes minus cosine of r, and then I put 0, it becomes 1. So it becomes minus 1 positive. But what is your opinion about this limit? limit of 1 minus cosine r when r goes to infinity. What? It's cosine is bounded. The point is that this doesn't become infinity, because cosine, even though r becomes infinitely large, cosine is between -1 and 1. But the point is that this function does not have any limits at all. Yes, because by making r bigger and bigger, these numbers are not getting closer and closer to one particular number. They oscillate up and down. Yes. So this means that this limit does not exist. This means that this integral is divergent, but not divergent to infinity, just simply diverges. So I would say that integral from 0 to infinity sine x dx diverges, not to infinity. In the previous case, I can say it diverges to infinity, but here simply diverges. Did you have questions? No? Is that clear? Yes? Okay. And then you might ask, what happens for the other scenario? Do you remember I told you that there are 3 scenarios? What happens if I have this? Okay, so first of all, don't do this. They are not exactly the same. There is no time. Probably I will bring you an example. I haven't written an example here, because some people think in this way. Limit of minus r to r f of x dx when r goes to infinity. It seems reasonable to define it in that way. Okay, but that is not the definition used. Okay, so this is not the definition. The definition is this: integral from minus infinity to infinity f of x dx is defined to be integral from minus infinity to 0 f of x dx, and then plus integral from 0 to infinity f of x dx. We say that this integral converges if and only if these two integrals converge, and then the sum of them is the answer to this integral. So if one of them converges but the other one does not converge, we say that this integral does not converge. So by definition, this integral is called convergent if and only if both of them converge. And if it converges to, say, 5, this converges to, say, 7, then this one converges to 5 plus 7, 12. Okay? So let me just solve this problem and we stop there. Okay? So for example, let us understand what is your opinion about this integral minus absolute value. We want to see if this integral is convergent or divergent. Okay, so you immediately see from minus infinity to infinity, you need to remind yourself about the definition. So you define it in this way: from minus infinity to 0, and then plus 0 to infinity. Yes? So, and then let me call this one integral number 1, and then let me call this one integral number 2. I have to calculate these two. So for calculating integral number 1, I have to use my definition. What was my definition? It was the limit of integral from r to 0, r goes to negative infinity, e to the power of minus absolute value of x dx. Okay? But I have to get rid of, as always, get rid of the absolute value sign. Can I get rid of the absolute value sign here? The answer is yes, because this interval is on the negative side. So x is always negative, so I remove the absolute value, but the price that I have to pay is to multiply by a minus sign. So this means that this becomes the limit, r goes to minus infinity. This becomes integral from r to 0, e to the power of positive x dx. Is that understandable? So because if I ask you, is x positive or negative, you say that in this case, x is definitely negative. When it is negative, it means absolute value of x is negative x. So this becomes positive x. Yes? And then I calculate this one, which is simple. So this becomes e to power x from r to 0, r goes to infinity, minus infinity, sorry. This becomes 1 minus e to power r, but r goes to minus infinity. Okay, can you tell me what's the answer? What's the answer to this limit? What? R goes to negative infinity. So the exponent becomes negatively large. So it becomes 0, yes? So this becomes 1. Okay, I have to calculate the second one, I2. So I2 becomes the limit of this integral, but in this case, absolute value, I don't need it because it is on the positive side. So this is just x, but there is a negative sign involved. So this becomes integral from 0 to positive infinity e to power minus x dx. Sorry, let me write it r goes to infinity. And if I calculate that integral, it becomes minus e to power minus x from 0 to r goes to infinity. So this becomes the limit of r goes to infinity. This becomes what? 1 minus e to power minus r. And the limit, the gain is 1. Yes? Okay, so this means that this integral actually converges to 2, because this was 1, this one was 1, this one is also 1. So this means that this integral converges to 2. Yes? Okay. Any questions? Okay, thank you. So we will continue with this topic the next 2 sessions. Okay.